When we look into this question of suitable conditions, we find that in addition to event particles, all the other relevant spatial and spatiotemporal abstractive elements can be defined in the same way by suitably varying the conditions. Accordingly, we proceed in a general way suitable for employment beyond event particles. Let sigma be the name of any condition which some abstractive sets fulfill. I say that an abstractive set is sigma prime when it has two properties, one, that it satisfies the condition sigma, and two, that it is covered by every abstractive set which both is covered by it and satisfies the condition sigma. In other words, you cannot get any abstractive set satisfying the condition sigma which exhibits intrinsic character more simple than that of a sigma prime. There are also the correlative abstractive sets which I call the sets of sigma antiprimes. An abstractive set is a sigma antiprime when it has the two properties, one, that it satisfies the condition sigma, and two, that it covers every abstractive set which both covers it and satisfies the condition sigma. In other words, you cannot get any abstractive set satisfying the condition sigma which exhibits an intrinsic character more complex than that of a sigma antiprime. The intrinsic character of a sigma prime has a certain minimum of fullness among those abstractive sets which are subject to the condition of satisfying sigma, whereas the intrinsic character of a sigma antiprime has a corresponding maximum of fullness and includes all it can in the circumstances. Let us first consider what help the notion of antiprimes could give us in the definition of moments which we gave in the last lecture. Let the condition sigma be the property of being a class whose members are all durations. An abstractive set which satisfies this condition is thus an abstractive set composed wholly of durations. It is convenient then to define a moment as the group of abstractive sets which are equal to some sigma antiprime where the condition sigma has this special meaning. It will be found on consideration, 1, that each abstractive set forming a moment is a sigma antiprime where sigma has this special meaning, and 2, that we have excluded from membership of moments abstractive sets of durations which all have one common boundary, either the initial boundary or the final boundary. We thus exclude special cases which are apt to confuse general reasoning. The new definition of a moment which supersedes our previous definition is, by the aid of the notion of antiprimes, the more precisely drawn of the two and the more useful. The particular condition which sigma stood for in the definition of moments included something additional to anything which can be derived from the bare notion of extension. A duration exhibits for thought a totality. The notion of totality is something beyond that of extension, though the two are interwoven in the notion of a duration. In the same way the particular condition sigma required for the definition of an event particle must be looked for beyond the mere notion of extension. The same remark is also true of the particular conditions requisite for the other spatial elements. This additional notion is obtained by distinguishing between the notion of position and the notion of convergence to an ideal zero of extension as exhibited by an abstractive set of events. In order to understand this distinction, consider a point of the instantaneous space which we conceive as apparent to us in an almost instantaneous glance. This point is an event particle. It has two aspects. In one aspect it is there, where it is. This is its position in the space. In another aspect it is got at by ignoring the circumambient space and by concentrating attention on the smaller and smaller sets of events which approximate to it. This is its extrinsic character. Thus a point has three characters, namely its position in the whole instantaneous space, its extrinsic character, and its intrinsic character. The same is true of any other spatial element. For example, an instantaneous volume in instantaneous space has three characters, namely its position, its extrinsic character as a group of abstractive sets, and its intrinsic character which is the limit of natural properties which is indicated by any one of these abstractive sets. Before we can talk about position in instantaneous space, we must evidently be quite clear as to what we mean by instantaneous space in itself. Instantaneous space must be looked for as the character of a moment. For a moment is all nature at an instant. It cannot be the intrinsic character of the moment. For the intrinsic character tells us the limiting character of nature in space at that instant. Instantaneous space must be an assemblage of abstractive elements considered in their mutual relations. Thus an instantaneous space is the assemblage of abstractive elements covered by some one moment, and it is the instantaneous space of that moment. We have now to ask what character we have found in nature which is capable of according to the elements of an instantaneous space different qualities of position. This question at once brings us to the intersection of moments, which is a topic not as yet considered in these lectures. The locus of intersection of two moments is the assemblage of abstractive elements covered by both of them. Now two moments of the same temporal series cannot intersect. Two moments respectively of different families necessarily intersect. Accordingly, in the instantaneous space of a moment, we should expect the fundamental properties to be marked by the intersections with moments of other families. If M be a given moment, the intersection of M with another moment A is an instantaneous plane in the instantaneous space of M, and if B be a third moment intersecting both M and A, the intersection of M and B is another plane in the space M. Also, the common intersection of A, B, and M is the intersection of the two planes in the space M. Namely, it is a straight line in the space M. An exceptional case arises if B and M intersect in the same plane as A and M. Furthermore, if C be a fourth moment, then apart from special cases which we need not consider, it intersects M in a plane which the straight line A, B, M meets. Thus there is in general a common intersection of four moments of different families. This common intersection is an assemblage of abstractive elements which are each covered or lie in all four moments. The three-dimensional property of instantaneous space comes to this, that, apart from special relations between the four moments, any fifth either contains the whole of their common intersection or none of it. No further subdivision of the common intersection is possible by means of moments. The all or none principle holds. This is not an a priori truth, but an empirical fact of nature. It will be convenient to reserve the ordinary spatial terms plane, straight line, point for the elements of the timeless space of a time system. Accordingly, an instantaneous plane in the instantaneous space of a moment will be called a level. An instantaneous straight line will be called a rect, and an instantaneous point will be called a punct. Thus a punct is the assemblage of abstractive elements which lie in each of four moments whose families have no special relations to each other. Also, if P be any moment, either every abstractive element belonging to a given punct lies in P, or no abstractive element of that punct lies in P. Position is the quality which an abstractive element possesses in virtue of the moments in which it lies. The abstractive elements which lie in the instantaneous space of a given moment M are differentiated from each other by the various other moments which intersect M so as to contain various selections of these abstractive elements.